Welcome back. Okay, let's dive straight into this explainer, where we're going to unpack exactly how to master the principles of microphones and speakers for your Cambridge computer science exams. Think of this like studying an ancient martial art. We are treating your exam strategy like the way of the last samurai, where ancient warrior wisdom meets modern exam strategy, and you learn to slice right through these complex questions with absolute precision. If you're studying the 9618 syllabus, or honestly even building foundations in 0417, 0478, 0983, 0984, or 2210, you already know the painful truth. Understanding the raw hardware is literally only half the battle. The real challenge, the place where most students either secure their top grade or lose agonizingly easy points, is in how you communicate that knowledge to the examiner. I want you to picture two types of students. First, there's Alex. Alex overloads his answers with every raw computer science fact he can remember, but zero actual analysis. Then there's Sam. Sam rushes against the clock, completely misses the command word requirements, and leaves huge gaps in his logic. Today, we are opening up the examiner's playbook to fix the mistakes that Alex and Sam are making, showing you exactly what the markers are looking for when they ask you about the principal operations of microphones and speakers.
Now, what's really interesting about this slide is that it reveals the ultimate trap students fall into, ignoring the specific scenario provided in the exam. This is exactly where our friend Alex loses all his marks. He sees the word microphone and he just starts fact dumping. He writes down everything he has memorized about analog to digital converters, diaphragms vibrating inside magnetic fields, you name it. But then he looks at his paper and sees it's covered in red pen marks. Why? Because the principal examiner reports are crystal clear on this. If the question asks about a microphone used in a noisy, heavy machinery factory environment, and your answer describes a pristine studio recording setup without ever mentioning background noise cancellation or directional capabilities, you are leaving massive marks on the table. Context is absolutely king here. You have to tailor your sword strikes to the specific opponent in front of you.
We are going to break this down systematically, starting with the classic exam traps, moving through the core theoretical principles, mapping out the procedural framework, and finishing up with critical evaluation skills.
Let's start with Section 1, the classic exam traps, and look at exactly where students lose the easiest marks.
So the crucial point here is that examiners are actively looking for specific, context-driven answers that account for boundary conditions rather than just isolated memorized facts. Let's look at that first bullet point, vagueness. Saying the computer processes the sound isn't enough. You need specific technical details, mentioning the sampling rate, the resolution, and how the analog acoustic wave is quantized into binary data. The second point is massive, and it's exactly where our other student Sam fails. Sam rushes through and completely ignores edge cases. What happens when the sound frequency exceeds the Nyquist limit for your sample rate? Do you get aliasing? Top candidates always address these boundary conditions. And as we just discussed, the third point is all about context. The examiner gives you a scenario for a reason. Use it to anchor every single point you make. Before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, Core Theoretical Principles. Let's talk about building a connected, conceptual understanding.
Simply put, you must be able to take established principles like systematic analysis and evidence-based reasoning and apply them to new, completely unseen problems. This is what Cambridge refers to as connected conceptual understanding. It means you don't just know what a digital to analog converter does inside a speaker, you understand the causal relationship of how changing the bit depth actively impacts the physical output of the sound wave. More importantly, when the exam throws a completely unfamiliar hardware setup at you, you can transfer these core definitions to figure out how it must operate. This is where we need to introduce the PEL framework. That stands for Point, Evidence, Explanation, and Link. Top students use this framework to structure their computer science answers. You make your point about the microphone's operation, provide the technical evidence like the ADC conversion, explain how it works in this specific scenario, and link it back to the overall system requirement. It's an absolutely foolproof way to guarantee you're hitting the assessment objectives.
And this brilliantly illustrates why integrating your knowledge with other syllabus areas is the secret to unlocking the highest grade bands. A true samurai doesn't just know their weapon, they know the terrain, the weather, and the opponent's footing. If you look at the left side of the slide, studying microphone and speaker principles in a vacuum is a guaranteed recipe for distinctly average marks. But look at the right. The principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. So, when discussing a microphone, don't just talk about the physical diaphragm.
Connect it to data transmission speeds. Connect it to file size calculations. Connect it to data compression techniques, both lossy and lossless. Show the examiner that you understand how the microphone fits into the entire computer system architecture.
Now for Section 3, the procedural framework. Let's execute what the examiners call the method mark strategy.
This means your data interpretation skills, like extracting information from binary representations and performing calculations, must be clearly documented step by step. Imagine looking at your past paper and watching all those red pen marks suddenly transform into green check marks. That's what this blueprint does. Let's say a question asks you to calculate the required storage for a 10-second audio clip recorded by a specific microphone at a certain sample rate and bit depth. Even if exam stress kicks in, your brain completely freezes, and you multiply wrong at the very last step, you can still get almost all the marks if you have laid out your formula and process clearly. The method is what proves your understanding to the examiner. Never, ever just drop a final number on the page. Always show the detailed journey of how you got there.
If you follow this exact, standardized sequence when tackling a question, you ensure that every single potential method mark is captured. First, deconstruct the question. What is the command word? Are they asking you to describe, evaluate, or compare? Sam misses this all the time because he's rushing. Next, extract the relevant data from the scenario. Then select your analytical framework, like the Peel structure we discussed earlier. Execute with clear notation. And finally, and this is absolutely huge, present it using the correct terminology. Don't say, the sound piece goes into the computer. Say, the analog acoustic wave is captured by the sensor and passed to the analog to digital converter. Precision in your vocabulary signals supreme competence to the examiner. It proves you belong in that top-grade bracket.
When the question shifts to practical application, examiners want to see this exact chronological flow from design all the way through to performance evaluation. Even in hardware topics like microphones and speakers, you might be asked how a driver program interacts with the physical device. If you are asked to outline a solution for processing the audio data stream, you start by designing the logic. Then discuss how it would be implemented in code. Explain how you would test the boundary conditions, like a sudden, massive spike in audio volume, and finally, evaluate how efficiently the program handles the data. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Finally, we reach Section 4, critical evaluation skills. Let's talk about thinking critically, just like an examiner.
Welcome to the interactive part of our workshop. It is not enough to just list facts. You have to use comparative connectives and draw justified conclusions to prove your analytical depth. I want you to mentally scan the screen and think about how you tackle a challenge here. If a question asks you to compare a dynamic microphone with a condenser microphone for a specific podcasting use case, do not just write a paragraph about microphone A and then a separate isolated paragraph about microphone B. You need to intertwine them. Use template phrases like, whereas microphone A utilizes electromagnetic induction, microphone B relies on changing capacitance. You must identify both similarities and differences, back them up with hard technical evidence, and explicitly state which one is better for the specific context provided in the question. Find the flaws in your current writing style and fix them with these connectives.
This table is your ultimate cheat sheet for evaluating algorithm quality, showing exactly how top-scoring candidates analyze trade-offs and limitations. Think of this as a data scan challenge. When you're looking at processing audio data from a microphone, how fast does the algorithm run? That's your time complexity. How much RAM does it chew up, storing that uncompressed high-resolution audio buffer? That's your space complexity. What happens if the mic gets unplugged mid-recording, or the buffer overruns? Those are your edge cases. Top-scoring candidates don't just say an algorithm is good. They constantly evaluate these specific trade-offs and openly acknowledge the limitations of any proposed system.
By using this specific deconstruct, solve, evaluate problem-solving framework, you naturally provide the evidence-based reasoning that examiners are actively hunting for. It is the ultimate fail-safe. If you were doing a speed writing challenge right now, you'd want to internalize this workflow. You identify what you know, break the problem down into logical steps, solve it systematically, and then, this is the critical part, you step back and ask, does this answer actually make sense? If your calculation says a simple 5-second voice memo takes up 4 terabytes of storage, well, you have definitely made an error somewhere. Check for reasonableness and then make a highly justified recommendation based on your findings.
So, to wrap things up, we are presenting the complete computer science answering system. Mastering microphones and speakers isn't just about the hardware components. It is about proving your systematic processing and analytical depth to the examiner. Remember these 3 golden rules that guarantee top marks. First, never give generic answers. Decode the command words and always link your answer to the context. Second, rely on the method mark strategy by showing your step-by-step process and applying the PEL framework perfectly. And third, manage your time so you can embrace cross-topic connections and evaluate trade-offs deeply. This is the blueprint.
I want to leave you with this crucial question to reflect on, because addressing those hidden edge cases might just be the exact key to securing your top grade. As you review your past papers tonight, look at your answers and ask yourself, what happens at the extremes? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.